You should have your lecture notes for Lecture 3 out and ready to fill in. A population of data is the entire data set for the question or issue we're considering. This doesn't want to write here. For the issue we're considering. For example, suppose we're interested in the average age of jury students. All right, so the population of data here would be the set of ages of all jury students. And I think I'm going to switch markers here. This is a bit of a struggle to get that to come out. Yeah, I hope that's readable. I can look off to the side here and see what I think is your view of it, and that's a little hard to read, so let me see if this is better. All right, so we're interested in the average age of jury students, so the population of data would be the set of ages for all jury students. A sample of data is really just a subset of the enveloping population, which I will start abbreviating as POP. So, for example, we're interested in the average age of jury students. Okay, a sample, maybe just pick the students in this class. All right, that's not taking everyone. If it's taking everyone, we'd be, or before, getting the population. Just pick the students in this class, and we have a sample. We have a subset. If we compute the average age there, maybe that says something about the average age of all jury students. Of course, you will notice that it's a very specific sample I'm picking here. I'm not being very random. I'm just picking all the students in this class. That may not make it a representative sample, and we'll talk more about representative samples of a population soon enough. But that's certainly a sample. Let's see. We've got two more things to define. I think I can get them in here. A parameter is a usually numerical value, you just say number, is a number that describes something about a population. All right. So for example, if we talk about the average age, so this is an example, average age of all Drury students the symbol we often use for the average of a population, by average I mean the mean, which we'll talk more about later, but you all know how to compute a mean. You add everything up and divide by the number of things you have, right? So this is not, R doesn't want to come up. This is not, I'm not being real esoteric here. I'm just, I just want to introduce the symbol then for the mean or average of a population, and the symbol is, I better put it right here to make sure I get it, is the Greek letter mu, all right? A statistic is usually a number that describes something about a sample as opposed to a population. So for example, I'm going to run out of room here. I think I'm going to stick it right here to make sure I get it in. For example, what we call, as up here, we call this the population mean. The pop mean. The sample mean. So if we wanted to take the average or the mean of all the students in our class, and where that is, I think of that as a sample of the population, then the sample mean we usually denote as X with a bar above it. X is kind of a generic letter to mean a data point, and anytime you see a bar above something, that often means the average or the mean. So X bar means the average of the data in the sample, all right? Not surprisingly, we will find that when we're dealing with a huge population, suppose we want to try to figure out what the mean is, the population may be too big for us to gather all the data of, so we will instead get a sample, and if what you want to do is figure out the population mean, not surprisingly, we'll compute the sample mean, and that will be what we call our estimate of the population mean. So let me just write that here. It's the estimate, should say sample estimate, of the population mean mu. That's what X bar will be. I'm getting a little bit ahead of myself, but that should make sense to you, and it'll make more sense as we get going a little farther.